Hello everyone, I'm Tom Morton and you are watching our Phase 3 solar installation video. This is our final phase of our installation, Phase 3. We actually installed our solar system in 3 phases. Phase 1, we put solar panels on the roof and connected them to our existing batteries. Phase 2, we upgraded our battery system to operate at a 24-volt system utilizing a Tesla Model S battery. And in Phase 3, we are connecting an inverter to the battery system so that we can light up the entire RV's AC system and have power anytime we need it. In this video, I'm going to be walking you through the Phase 3 part of this installation. As always, we're going to start out with a schematic that's going to be available on our website for you to download. We're going to reference this through the installation, so hopefully it'll help you follow along what we're taking a look at. We're going to start here in the power cabinet. We talked a lot about this in Phase 2 video. If you want to know details about all that's going on in here, definitely reference that video. But we're going to take a look primarily at how this is connected to our inverter. Internal to the RV, we utilize power in either a 12-volt DC fashion, which the 24-volt battery cannot supply, so the little converter that we have in this box is actually producing that 12-volt DC, and that goes to run our lights, the electronics for the fridge, our water pump, and a few other things inside the RV. The other conversion that we need to do is convert it to 120 volts AC so that we can run our outlets, our air conditioning units, and anything else in the RV that runs off of 120 volts AC power. That is accomplished utilizing an inverter. And starting in this cabinet, if you look at our schematic, we start off here with a 24 volt system and we show the 2 wires running over to our inverter. And in this box here, that is this wire and this wire right here. They come off of our 24 volt DC bus that are between these 2 bus bars here and run over to the inverter. Now we're utilizing a 3000 watt 24 volt inverter, so it's getting power directly from the battery. Now this is where the 24 volt system really shines. Because of the higher voltage, the amperage is lower and we can use much smaller wires than you would need on a 12 volt system. These wires run back to our inverter that are located in a different cabinet. Let's go back and check out where the inverter is. That electrical cabinet is located about here in the very front of our RV. The wires then run up and over top of our basement to where our inverter is located right back here. The cables for the inverter run over my head along this duct here and run into a utility compartment behind this panel here. This is where we installed our inverter. It is a ways from the battery, and typically that is not recommended to do. You want to try to keep it as close to the battery as possible, but our cable run is only about 8 feet and we're well within the voltage drop tolerance specs at 150 amps full load on this. We chose to install the inverter in here for a number of reasons. It was along the AC path that we were going to be utilizing to actually power our breaker panel and use the incoming power. And also we wanted it out of the storage area in the RV. This is also the location where our existing battery charging unit was located. So we removed that and this inverter was installed in that location. On our schematic here, this blue box is the Victron Multiplus 24 3070 inverter. The number on the unit means that it's a 24 volt unit, 3000 watts continuous load capability on it, and the 70 is the charging amperage that it can actually charge the battery at. On the schematic, you'll also see that it has 120 volt AC in and the 120 volt AC out, and those are these green wires right here. The last part connected to this inverter is the enable circuit, and that's this little wire right here. We'll show you where that goes when we go inside to look at the control panel. Basically how this unit is wired is it gets the 24 volt DC power that runs into it, and it converts that power to AC. Most inverters you install in an RV are an inverter charger unit, so they require 120 volt power, so that when you're plugged into the shore, this unit will actually backfeed. It'll send power back along these cables to the battery to charge the battery from shore power. That's why there's a 120 volt input side to this inverter. In addition, on this particular inverter, however, it's also a hybrid inverter, which means we can actually use some of that power coming in from the grid and combine it with the power from the battery to get even more power on the output for our 120 volt system. That means we can do some really fun things like use our small 2000 watt Honda generator, combine it with solar power, and run things like our air conditioner, which we were not able to run before on the generator alone. Installing the inverter in here was pretty straightforward. You can see I was very limited on space in here. This is our black tank, which it is kind of sandwiched in between, and unfortunately our water pump is really close to it as well, right here. Ideally, I'd rather keep it away from these units in case there was ever a leak, but we did elevate the unit off the ground here so that if we did get a big puddle, it wouldn't actually get underneath it and get into the unit. Ultimately, we would like to go with a composting toilet at some point and remove this black tank altogether, which will give us a whole bunch of room to reconfigure it in here. Now, installing an inverter like this, not only do you connect up the wires to where they need to go, the DC wires connect to the DC bus inside the inverter, your AC input, there's a terminal block inside the inverter that you connect that to, and then your AC output has a terminal block as well that you need to connect it to, along with the grounds, which are here and here. The grounds need to be connected both to the frame of the RV and all the way back to your actual distribution panel. Now, this is a unit that I got unused, but an older model, and I was not actually able to program this unit utilizing a computer. Most of these units, however, you'll plug it into a computer, get into the software, and set up all the charging parameters for your battery, any hybrid functionality, and other parameters on the computer. But this unit, I actually had to get in and change around dip switches and look at little flashing LEDs and actually tap up and down buttons to program it according to what I wanted it to do right inside the unit. I had to do that all when it was out because I cannot actually access this unit very well in this configuration. And once I had everything wired and it all programmed, then I lifted it up and installed it in this location. And I've got a couple screws on some woods. It's easy to get it in and out, but I screwed it down and it's pretty firm in this location right here. Some of the parameters you'll need to program in an inverter like this is your charging voltages, your upper limits if you're running lead acid batteries, when you want it to do an absorption phase, if you so choose to do that, your float and bulk states. On the lithium, basically I've got this thing set to charge it up to 24 volts and just go no higher. It's a steady charging state and it doesn't do anything else to the battery. We'll talk about actual charging parameters for the Tesla battery specifically, but also lithium batteries in general in a later video. Other parameters that you'll need to set specifically on a hybrid inverter is how much power you want it to limit on the input side. The beauty of the hybrid units is you can tell it not to draw any more than, say, in our case, we told it not to draw any more than 11 amps from the shore when it's set in the hybrid mode. And what that does is we can run our little generator without overloading it. That maximum amperage draw parameter can be changed on these units, and you can get remote controls that are connected to this cable right here that you can actually dial that up or down, or on a screen, or on your computer, or even on a wireless app on some of these inverters. It's nice to be able to adjust that because say you're on a 20 amp circuit just plugged into someone's house and you want to be able to run your air conditioners and everything, you can set it at say 18 amps and it won't draw any more than that so you don't trip the breaker. But if you do need to draw more than that for a short period of time, it'll use the batteries or the solar system to run that power load, combining it, utilizing that hybrid technology inside the inverter. So we've now taken a look at the inverter itself, the input and output lines, the 120 volt in and out. I wired these both with 10 gauge wire because it was well within the specs of the amount of power that we're going to be drawing from this inverter. And these wires then run back to our manual transfer switch that then powers the RV. Let's head inside and take a look at that switch, and we'll talk about different ways that you can connect these inverters to your RV. All right, we are inside our RV now, and we have our panel door open to our utility compartment in here. We've got a lot of electrical stuff going on. This is our primary breaker box, our 120 volt distribution panel. This right here is our 12 volt distribution panel that has fuses that go off to the various things and lights in the RV. This is where the power from the 12 volt converter that's up in that electrical cabinet comes into. This is the new piece that we added with the inverter. This is our manual transfer switch. There are lots of different ways to wire an inverter into your RV or house, but we chose to do it this way because it gives us the options that we were wanting. Let's first walk through the operation of this box. So there's two switches on here. The big switch on the right is the actual transfer switch that allows us to select the power source that is actually powering the whole RV. In the current position, we have it labeled shore/generator. If we have the switch in this position, the power bypasses the inverter completely and goes straight into the breaker panel to power the entire RV. This little red switch over here provides power to the inverter from the 120 volts AC. And if we turn this on while it's in the shore/generator position, it's going to provide 120 volts AC power from the generator or the shore power to the inverter. But the inverter is not actually powering anything in the RV from its 120 volt side, but it will act as a battery charger and charge the battery if this switch is on. Turning this switch, there is a middle position that just shuts off the system completely. The RV now has no AC power. If you switch it over to inverter, now the inverter can use the DC power, the 24 volts from the battery and solar system, convert it to 120 volts, and in this position we have it wired so that it lights up all the breakers in this panel and powers the entire RV. With this switch in the off position, the inverter is only going to get power from the battery and convert it. But if we switch this switch on and we are still plugged into the shore power or the generator, this is where the magic of a hybrid inverter can happen. With this switch on, we're providing 120 volt power to the inverter if it's available. And what the inverter will do is it will take that power and pass it through the inverter into the RV, but only up to the amperage that you set on the hybrid inverter. If your loads in your RV draw more than the amperage that you set the hybrid functionality to, the inverter will make up that power from the 24 volt battery system. This is where we can plug our small Honda generator into our RV, turn this switch on in inverter mode, and we're going to draw up to, we have it set at 11 amps off the generator, and anything beyond that it'll draw from our battery and solar system. During the day, if it's a sunny day, we can run our AC off our small generator and combine it with the power from the solar and not even discharge the battery at all. We only need a couple hundred watts on top of the generator to run our AC all day long. So with these 4 different configurations, inverter, shore power, inverter power on or off, we can really tailor our power needs to the hookup situation that we have on hand. Now I modified this cabinet to install this box in here. I had to cut out the wood in here, and this is the original power cable that went directly into our breaker panel. I pulled that power out and I ran it into the transfer switch on the bottom side of this box. Power also comes out from this switch and comes up, and you can see the cables here that now go into the box that come from this switch. Lastly, we have power coming in from the inverter that comes in along the same green wires and goes up under the bottom as well. And all the wiring is done inside this box. So now that we know the functionality of how this unit works, let's talk about how it's actually wired. The shore power wires on the schematic come in from the right-hand side, and that is this big wire right here. In this wire, there are actually 4 different cables. There are 2 hots, a neutral, and a ground wire. The ground wire is the simplest. It just passes through this box. It bonds to the ground in our main breaker panel. It bonds to the frame of the RV, and it also runs over and connects to the grounds in the inverter. The 3 power wires, however, are a little bit more complicated. Because this RV is a 50 amp RV, the connection to it is actually the same as you would see in a residential household in North America. It utilizes the split phase AC system. So RVs, when they're plugged in, are either plugged into a single leg or 2 legs of the AC system. A 30 amp plug is basically the same type of plug receptacle that you would see just in a normal household where you just plug something into the wall. Instead of being 20 amps, however, it's got a little bit more power. The wires are a little bit bigger, but basically in this situation, you've got a hot wire that comes off one plug and a neutral wire that comes off the other side. And between these 2 wires, if you were to measure it, you're gonna see 120 volts. The third wire up here is the ground. That's going to go to the RV and ground to the frame of the RV. Now the 50 amp plug is the same as how a residential household is wired. In this case, you actually have one of the wires coming off is a hot. One of the other wire coming off is also a hot, and the wire in the middle is the neutral. So what this means is that if you measure from here to here, you're going to see 120 volts. If you measure from this hot to neutral, you're also going to see 120 volts. However, if you measure from this leg to this leg, you're going to see 240 volts. Real quick, the reason why this is called a split phase system is that in AC, alternating current, the voltage and current actually looks like a sine wave, something like that. And if you were to measure from here to here, you would see 120 volts. This is at the peak amplitude of the sine wave. This is the sine wave for one side of the leg, but the other leg sine wave is going to be completely inverted. It's going to look like this. Now, if you use the power across both of them, if you basically overlay these two sine waves on top of each other, you're going to see something that looks like this. And if you now measure the voltage from top to bottom at the peak, this is where your 240 volts comes in. Now in RVs, the 240 volts between both legs is rarely ever used. You really only use this with really high power appliances. I have seen people put in some 240 volt washer dryer units and things like that, but for the most part, RVs only use one leg at a time to power all the receptacles. But you do kind of want to try to balance the load so that you have approximately the same amount of load on each leg. In the case of a 50 amp circuit in an RV, the three wires come down and land on the breaker panels, and typically you have basically one breaker here on this side and a breaker on the other side, so that what's happening is that half your breaker panel is going to be powering half of the RV and the other half is going to be powering the other half of the RV. And if you were to lose one of these legs, the other side's going to work at 120 volts, but half your RV is not going to function. The problem that we have with an inverter, if you're going to try to power an entire 50 amp RV with a inverter that only provides one 120 volt leg, a hot and a neutral, you're only going to be able to light up half the panel. That is one of the options to connect the inverter, is just connect it to half the power and let the other leg turn on when you connect to shore power, but you're not going to be able to light up all the outlets and everything in the RV. You're going to have to be selective. One way to get around this is with the inverter right here. You basically can break one of the legs, come over and connect down here, and now instead of being 240 volts across these, it's actually 0 volts between these two lines, but this line and this line are still 120 volts on each side. This means that if you do have any 240 volt appliances, they will not work on the inverter, but you will be able to light up all of the breakers in your panel and run the entire RV off of one leg or a 120 volt inverter. And that's exactly what we do in our wiring. In the inverter, where the power comes from the 120 volt out, we land on the back side of the switch and we jumper from one pole down to the other, so that when the switch is switched to the inverter position, it's actually lighting up both sides of the panel with 120 volts from the inverter. So now that you understand the reason why we wired it this way, if you look at the diagram, you'll basically see that the shore power here falls onto one side of the switch. The middle of the switch has the wires that come off the bottom and come over to our breaker panel, and the inverter power both leaves this box and goes over to the inverter to provide the pass-through power and power the inverter if we're going to use it as a battery charger, and also comes back in to land on the switch and flow through into this box if we so choose to power the RV from the inverter. Now the switch in here is a panel mount switch. It's mounted to the front of this box, which makes it a little bit difficult to deal with all the wires coming up. I had to basically pull the wires up through the conduit in the bottom of this box, wire it all with the panel out, and then put it back up on here. But the switch was large enough that it allowed me to use the terminals on the back of the switch to actually make these connections, like where the power flows over to the switch and over to the inverter, and also the jumper cable and everything. We were able to do that all right on the switch in the back of this box. This switch right here is also a breaker in addition to the switch. We are providing our inverter with 20 amps AC, although we have it currently limited to draw only 11 amps. Our inverter can only draw about 20 amps, but some inverters can draw 30 or even 50 amps single phase, and also use that for hybrid functionality if it's a hybrid inverter. We are currently using the Victron Multiplus, and the entire Multiplus line are hybrid inverters and have this functionality, but there are other manufacturers out there that make hybrid inverters as well. So that about wraps up how we connect the power from the inverter to the RV. Let's now take a look at this last piece, the actual circuit that enables the inverter to turn on. The last piece on our schematic here is this loop. We talked about this control wire a little bit down at the inverter as to where it goes. It comes up and goes first through this switch right here. This controls our inverter on or off. If we leave this in the on position, the inverter will fire up and it'll just run in standby if we don't even have it connected. But there's a little bit of a loss. There's a couple watts for it just to run its brain. So using this switch, we can turn it off and save even that amount of power if we're not using the inverter. We typically shut it off overnight, or if we're connected to the grid for an extended period of time, and we rarely ever, actually we've never charged our battery except for testing it from the inverter because our solar power almost always powers the batteries and our lights and everything in here. We'd have to have the inverter in the on position, however, to charge the battery from the shore power. The wires then run over to the backside of this battery monitor right here, where we actually have a relay contact that we can program to do all kinds of things. Originally, we were going to use that relay to close at a certain state of charge so that we could tell a second relay to power up our electric water heater and dump the excess solar power into our electric water heater once the battery was charged. We switched away from the electric water heater and we now use a Truma on-demand water heater, so we no longer needed that relay. So what we use that relay for now is to act as an over voltage protection for our battery. Because we're using the Tesla lithium-ion battery, we have to be very careful not to overcharge, undercharge, a whole bunch of different things. We go over a lot of that in our phase 2 of our battery protection circuit, but we're actually using this to monitor battery voltage, and if it gets too high, it opens this inverter on and off circuit and will shut down the inverter to prevent it from continuing to charge the battery when we're using it as a battery charger. So that about wraps up how we have our inverter wired. We talked about how it connects from the 24 volt system to the inverter, how we wired the inverter with its on and off circuit and the over voltage protection, how we wired power into the inverter using this switch right here, how we've got power back out of the inverter and it comes to the back side of our transfer switch, and we had to jumper that leg so that we have 120 volt power on both sides of the circuit. Also how we have power coming in from the shore of the grid to the other side of the transfer switch so that we can bypass the inverter altogether and use shore power if, say, the inverter goes down, or if we're just hooked up to 50 amp power at a campground or something and we're in the shade and we just don't need to run our inverter at all. All of that goes into our main distribution panel, and like we're currently on inverter and our solar is lit up, we now can do things like run our microwave on the inverter, we can run our induction cooktop, We have been able to use this for all kinds of different things. We frequently will cook in our Instant Pot. We cook a lot on our solar power. We'll run the fridge on solar power, on AC when we've got extra power. It's so nice. It works really, really well. And when we're out in the middle of nowhere, we hardly know that we're not connected anymore. Thank you so much for joining me as we walked through the installation of our solar system in our RV. This is the first pass, and as we make upgrades, we will definitely be sharing them with you and how they work. We'll also talk about performance, how this system in particular is working. I'm going to spend some time and talk about charging parameters for the lithium-ion batteries and tips and tricks for utilizing batteries like this. This is a very exciting time for solar power. There's a lot of new technologies coming out and improvements that are being made in it, and RVs are a really great application for solar power because we are frequently out in the middle of nowhere, and it's really nice to be able to have power all the time for whatever you need. I'm Tom from Mortons on the Move, and we will see you guys next time.